a joint session. We have Super Protocol and NVIDIA joining us, Nukri Basharuli, the founder and CEO of Super Protocol, and Michael O'Connor, Senior Director at NVIDIA. Happy to see you here, guys, and I'm passing the mic to you, please.
All right. Thank you for inviting me. My name is Michael O'Connor. I am a senior director at NVIDIA. I am the architect for confidential computing, as well as our AI enterprise and NVIDIA certified solution. So the first thing I kind of wanted to jump into was, confidential computing, how does it help me? And the premise is that data is this asset that we want to protect, and confidential computing is trying to protect the data in as many forms as possible. The protecting the data while it is actually in use is the new thing, right? So we all know how to protect data at rest, right, on the disk, right, encrypted. We know how to protect data in transport, TLS, while it is actually in use is the new thing. So protecting the data while so that it can't be read by anyone who shouldn't be reading the data. So only the user, right, is accessing the data. Similarly, the data that is being modified, the results of a computation in the environment should be exactly what is expected and not altered by any other host or any other mechanism. And lastly, physical attacks, trying to mitigate physical attacks from someone who has somehow physical access to your computing environment and has introduced interposition hardware, so that if they are trying to read the PCI bus or trying to read memory, that there is no ability to get any usable information from those mechanisms. What is not in scope is a denial of service attack. Those can be used to modify behavior, but those are out of scope for confidential computing, as well as a hypothetical physical attack. The GPU does have memory on the card, has high bandwidth memory, and interposition into that memory is most likely going to damage the GPU. And so we don't treat that as basically as a credible threat. So this is what confidential computing is trying to do, is to trying to keep the data to be used by the person who controls or owns the data. And this is kind of the reason why there are a lot of threats to data out there. As you can see, 80% of data breaches are cloud-based. This results in costs for analysis, costs for remediation. Sometimes there are fines, but there's no doubt that in the world of confidential computing, the big discussion topic is large language models. Not only do they have a lot of value for what they can do, there is a significant amount of sunk cost. So, for example, you can see here the size of large language models growing over time. In the last 4 years, state of the art, growing from 65 million parameters to 1.8 trillion parameters. And the larger the model, the more time it takes to train such a model, and thus the more cost you've sunk into the model. There was an article last year sometime talking about one of the GPTs taking 1,000 ampere GPUs on Azure for an entire month to train. So that's hundreds of thousands of GPU hours, which results in millions of dollars of sunk cost. And trying to protect that is key. And in turn, NVIDIA has tried to step up the size of the memory on the cards to try and keep up with that demand. We started all this with an 80 gig card, and now we're releasing a 140 gig card. But again, large language models have this enormous influence on confidential computing. So the use cases, formatting. These use cases of protecting the IP and the business value are key. And key to protecting the data. The federated learning is probably more aligned with where we are with Web3 in that protecting the data of the user is paramount. Yet you still want to have the ability to be cooperative. So in the federated learning case, you may have, just as an example, in a supervised learning scenario, you have 1,000 hospitals that each have 1,000 patients with, several sets of imagery for some kind of cancer detection. You now have millions of data items that could be used to create a better model that benefits everyone. The challenge is that the privacy of the data needs to be retained. So in the federated learning scenario, the model is what is shared and goes out to each of the hospitals or entities, whatever they are, and you train the model, and then you share the weights back, and then thus it becomes this cooperative mechanism. Similarly, there are fraud detection scenarios where banks and other financial institutions want to share information, but there is this privacy of the data that needs to be retained, but you want to make fraud detection better, or you want to do some other kind of analysis. Federated learning is a key tenet of trying to maintain the privacy or security of the data while still trying to make some kind of cooperative analysis. And then sovereignty and regulations more and more coming along, prescribing confidential computing to be key. The Web3 and super protocol use case, I didn't have time to add to this slide, but there is a blog coming out later this week, and keep an eye out for that, as it is a key use case around protecting data in the Web3 environment. So how do we visualize this, right? I've talked about the use cases. How is this architected? So as you'll see on the left image, when confidential computing is not enabled, it's your standard cloud mechanism. There is a host OS in the cloud that controls everything. There is a hypervisor, a virtual machine manager, if you will, that is launching virtual machines for users. And then the virtual machine has the driver that can talk to the GPU. In this case, the hypervisor has access to the GPU over PCI bus, as well as all of the memory on the host is accessible to the host, and all of the transfers, all the data transfers between the CPU and the GPU are plain text. So this is an example of a wide open system where if there was a physical or even a software attack, there would be the ability to glean a lot of information from the system. When confidential computing is enabled, there's a couple of really key differences. When the virtual machine starts up, it's going to secure boot and validate all of the drivers and make sure that they're signed correctly. Then the driver is going to contact the GPU and initialize the GPU to bring it up, which also has its own set of security processors to validate the environment, to check its own firmware, as well as initiating an SPDM session so that the communication over the PCI bus is encrypted at all times. Once that is done, then the PCI firewalls are erected to keep the host from accessing the GPU. Bar 0 is decoupled. A couple of registers do remain simply for management of the device and detection that the device is there. But otherwise, the system, the host and the hypervisor are completely shut off from what is going on in the virtual machine as well as on the GPU. And thus the CPU trusted environment has been extended to include the GPU, and then the two can work in tandem. So what does this mean for performance? Because there is a challenge with the communication over the PCI bus being encrypted. And so normally what I say is it kind of depends upon your workload on what the performance impact is. As you can see I have two charts here. One is a single GPU chart and the other is a multi-GPU. On the left is the single GPU. And you'll see that with confidential computing enabled on or off, the BERT BERT fine-tuning rather, is pretty much the same performance, whether confidential computing is enabled or not. Also, when you move up to the higher power of the SXM card versus the PCI card, you see a direct linear growth due to the extra power being available. And then on the right-hand side, you see one GPU on the left, but then 8 GPUs with the 700 watt cards. And you'll see that an almost linear growth from the higher batch size to be able to scale with the power. It all depends upon the ratio between the performance between the IO and the compute. I will say that moving forward, a lot of this challenge is being pushed down into the hardware. We are expecting next generation PCI buses to have this encryption mechanism built in, and thus not have any challenges with PCI encryption. And hopefully the plan is it won't simply be confidential computing; it'll just simply be computing. So where are we today? Last summer we introduced our first card. This summer we now have support for 3 cards, and we're adding a multi-GPU to it, and as well as growing our remote attestation mechanisms for a larger scalability, which is a nice lead-in. Well, I wrote the slides, but a nice lead-in to attestation. And this kind of speaks to the Web3 mechanism that, zero trust. Don't trust anything. On the other hand, you do need to work with the mechanisms that are in place at the cloud service provider, as well as the other mechanisms that are feeding information. So I guess the way I would really put it is that it's trust and verify so that you feel comfortable using the things that you want to have in your system, helping your computation. So an example of this is a healthcare provider and may not want to trust a system that it can't verify or it can't get information for, or a financial institution may not want to allow certain hardware to access any of its algorithms. And so the mechanism to resolve that is attestation. And so here is a kind of a overall a graph about how we view attestation. We conform to the RATS architecture. As you see at the center of this mechanism is a verifier. And that verifier can either be local or it can be remote. The user, and this is kind of the challenging thing with this slide, is translating the RATS architecture to like real world things. The relying party, that's the user, that's you. If I'm speaking to users, you need to make the decision about whether you trust this environment, whether you trust the CPU that is in your compute environment, whether you trust the GPU or anything in the environment. So it all starts with gathering the evidence from the attester, which, for example, would be a GPU, right? And the GPU is going to take a look at its firmware. It's going to check the fuses. It's going to get state, hash anything that's large, and then provide that report into the verifier. Similarly, the verifier is going to get reference values or golden measurements or what it expects the evidence to be from the attester so that it has a good understanding of what the state should be. And then lastly, a policy for evidence. This is a way of a side of allowing the verifier to have a bit of wiggle room. And again, that's up to the relying party whether it's going to allow with any wiggle room. You know, is an expired driver okay? That's just one version back, or is this one fuse? Can it be in any state? And then the verifier does the comparison and returns the results to the relying party. NVIDIA has stood up several services to support this. There is the RIM service, which is the where all of the reference manifests for all of our drivers and all of our supported cards are. This is the set of expected measurements. These are all each signed with a certificate. And then that's what the OCSP service is for. It will evaluate, or it will give an answer of whether the certificate used is okay, or if it has been revoked, or if it doesn't even know about the certificate. And this is how we handle a known vulnerability. So if a specific card for some reason would be found to be vulnerable, NVIDIA can revoke that. Or if there is a driver that is somehow out of scope, then the service can return revoke for that. The remote verifier, and then the remote verifier makes that determination. So last slide, I want to encourage people to be able to go to this link for getting more information on confidential computing, as well as try out Launchpad. It is a free service provided by NVIDIA to allow people to try out their applications on NVIDIA hardware that supports confidential computing. You just sign up, you can get a week or whatever, and it's free. And that's my last slide.
Thanks so much, Michael. I have to hand over the mic to Nukri, who is the next in this joint session. So Nukri, please go ahead.
Yeah, thank you, Mike. Thank you for your detailed explanation. And we are in close collaboration with NVIDIA. And as a part of it, we are now working on a series of blocks, and I'm excited to announce them shortly after this event. The first block on confidential and self-sovereign AI will go live. So keep an eye on the NVIDIA channels for its releases, and it's coming soon. In this presentation, I will explain why Web3 combined with confidential computing could be critical for advanced artificial intelligence projects. As you see, I will share some interesting insights from Ex Machina Group, a community of Web3 and AI founders. I did small research and investors. And to start, market researchers at Everest Group predict rapid growth of available market for confidential computing. And it's evident that AI will accelerate this growth. I see. Yeah, in recent years, there have been a boom in adoption of confidential computing technology by all leading vendors, right? Like Intel, Nvidia, AMD, ARM, and so on. This technology is spreading across all server chips and with advent of ARM to mobile devices as well. At the same time, privacy of sensitive data is becoming the standard for all vendors working in AI ecosystem. Same time, TE's trusted execution environment is actively used in a wide range of devices and applications we use every day. We trust it with our fingerprints, private messages, cryptocurrencies, and more and more. The widespread popularity of this technology is driving vendors to standardize it for the future integrations. And we see today, it looks like TEs will soon be presented on all devices, I believe, as a follower of this technology. And today, more than ever, confidential computing technology is becoming critically important. The rapid growth of AI technology demands the highest standards of privacy and security. I like this slide. We are witnessing a massive shift in AI infrastructure and investments in the United States, with the goal of achieving super intelligence by the end of the decade. This entails the rapid expansion of computing clusters and significant market mobilization. Same time, evolution is unstoppable, and we expect that the hundreds of million AI agents, I believe, could consolidate decades of algorithmic advancements into a single year, leading to creation of super intelligent systems, let's say, with immense power and potential, same time potential danger. And the future of artificial intelligence evolution heavily relies on the ability to share data and models between parties without exposing them. Retaining privacy and ownership rights. NVIDIA, Intel, and other leading players have used the confidentiality of models and data as essential for developing an efficient AI economy. But while millions are potentially ready to enter the AI economy, any potential asset exchange is hampered by risk of exposing confidential data and models. Regulators are more concerned than ever about personal data breaches, and companies are updating their policies to protect corporate data and proprietary AI models. You see it every day, right? And today, unsecured and unsafe collaboration in the AI field can destroy more value than it can create. Now, data and model privacy risks push teams to work in isolation while reserving valuable assets for exclusive partnerships. We saw it many times in corporate collaboration projects. And they are reserving under non-disclose agreements between multiple parties. Super protocol idea and a super protocol shares NVIDIA's vision of privacy, of course. Privacy is an enabler, and it will be superconductor for AI collaboration. First, we created a fully decentralized AI cloud based on confidential computing technology. It's 100% governed by smart contracts to prevent any third parties from interfering with users and data. Our marketplace for agents, for AI agents, models, data is built on top of this cloud. It's fully confidential and decentralized too. These two factors enable secure multi-party collaboration with preserving the confidentiality of everyone's models and data. Without the risk of asset disclosure, Super enables risk-free cooperation among all these who wish to contribute to improvement of model data, AI agents, and applications. A couple of examples in our, let's say, in our projects, what we do and working on. From our partners developing their solutions based on a decentralized confidential cloud. A personal AI assistant that learns from personal data, chats, calendars, and health data, my friend's project, and then helps optimize personal productivity, time management, and health. Of course, there will be dozens of popular AI agents that you will be using in same paradigm every day. For booking hotels and services, analyzing your financial data and planning, optimizing your communication style, creating personal nutrition and health plans. This is highly sensitive personal and data, transactional and family data. And of course, should not be shared with application developer or server owner. It's absolutely impossible. When users' data is not disclosed, the adoption of personalized AI assistants becomes much faster, and we believe this. Another interesting case where we play games where AI agents that you trained compete against each other. Compete against each other. And near future of gaming is to allow users to have AI-driven companions or teammates. User can invest in training, and they invest it now to upgrade them and better perform in combat and in game worlds. But same time, the problem with AI agents within traditional games based on centralized developer controlled environment is that the user never truly owns this agent. Developer can control it, can change it anytime for his own benefits. Super protocol allows build agents that are owned by you only. They are not on developer servers, and they are trained. Their training history is verifiable. What's most important, and their access keys can be packaged as a as an NFT, and you can rent it, or sold it openly on any on the market. Super makes this AI agent as a real world agent. A few words about our marketplace. Just imagine a zero disclosure marketplace where users can rent out their models and data to each other on flexible terms with smart contract processing these payments. Everyone assets can be used as building blocks for the AI community. And user can share any sensitive data with a decentralized application built on same paradigm on Super protocol. 1 million of users can participate in various value-adding roles, helping with data cleaning and labeling, model fine-tuning, and others, many other services using our marketplace. And of course, sometimes for revenue share from the ecosystem. With Super AI marketplace, basically you can design your relationships between your partners and in non-deterministic environment. Data and models usage scenarios could be programmed by smart contracts and cannot be secretly altered. Right, and confidential enclaves are verified even before you are loading data or application into them. Input and output is always verified. Data and models are securely verified. Convenient marketplace where everything is easily available in a one place. And few words about our timeline. This AI economy is not a distant future. Since 2021, we have already built a decentralized confidential AI cloud with support of Intel, Nvidia, and other vendors working in confidential computing area. Thousands of users successfully tested the testnet across 5 versions. The marketplace for AI agents, models, and data will be launched soon. The computing supply is almost ready, and we are preparing to start onboarding data, models, applications, developers, and community members in different roles to the marketplace through a comprehensive incentivization program. Every early contributor will receive incentives for bringing their assets to the marketplace and for providing value-added services like verification, the data preparation, or models fine-tuning, etc., etc. And for get early access on our website, early testers can request early access on our site. Just fill a simple application form and get access to the decentralized confidential computing for your AI experiments and future projects. Thank you so much.
Yeah, and Nukri, thanks so much. I will also soon send the links that you've shared with us to the materials and your website, and with the guidance how people can sign up. So we'll share that in the stream chat just soon. Also, we have a few minutes to answer additional questions that our audience has. Let me just remove the slides. Yeah, and Michael, where are you? For some reason, I believe that Michael has left. But anyway, I can see that he answered almost all the questions regarding NVIDIA in the chat. But there are a couple of questions about Super Protocol. And yeah, shall we start with... Let me look through. So this was, why is Super Protocol doing all this? What do you aim to achieve?
Nice question. I'm answering, and we have Michael. Maybe we can start with Michael.
Okay.
Yeah. Okay. But
I will remember my question.
Yeah, I can see that you've already started answering questions in the chat, but maybe you would like to share something just aloud because we have a few minutes, so no worries.
I mean, the strategy. So the first one was about the strategy, right? How strategic is CC for NVIDIA? I mean, it's always difficult to answer things like that, right? You know, how strategic is anything, right? But we're investing time. You know, I see confidential computing on the roadmap. As far as I have visibility into, we are investing time with partners. I think that's probably the true indication that something is strategic, is when it's not just you anymore working on something, but you've gotten partners to kind of believe in your message. So we have Azure with a confidential computing solution that's in private preview. We have GCP in private preview. So that's, I think, an indication that there is something in the market for confidential computing and that people want to see. And then the other thing I would add is at the CC Summit last week, large language models. I mean, people could not stop talking about large language models and confidential computing. So I think that is really what's going to drive a lot of that. But it also shows how important solutions like Web3 are, because it is about privacy of data.
Yeah, and about the vendors, I believe there was a question.
Vendors. So,
yeah.
So what the CPUs are what start the TEE, and so that's where kind of like a lot of the confidential computing origin is. We are extending it to include the GPU. So we rely on the CPU to have initialized the environment. AMD has a solution with their SEV, or they call it Infinity Guard technologies. And then Intel similarly has a solution with TDX. ARM has Realms, which is coming as far we want to include in a solution with NVIDIA. So I think the CPU technologies are there, and the NVIDIA is the first GPU to join in. I can't speak to other GPU vendors. And there was one last one.
Yeah, and there was one more
Yeah.
about the prospects, I guess. Were
what do you think the prospects are for the technology overall? Well, as I said, I think eventually it'll just be computing. I mean, it will be simply, this is how you get a virtual machine, and the performance will be free, if you will, right? They will push down, we will push down the computational challenges into the hardware so that there isn't any performance challenge. And when you get a virtual machine, it simply will be confidential, and that will be the new normal. I mean, why would you not?
Yeah, and getting back, thanks a lot. Yeah, getting back to the question that we asked Nukri. Well, I mean, the audience asked. I mean, I said that aloud, but we already asked that. So
you are part of auditory. Yeah, right.
Yeah.
As I remember why we do it. First of all, let's say it comes from my previous projects. We resolved many, let's say, issues of collaboration between companies and ecosystems using confidential computing. And today we have, I have a dream to make AI-based economy, to make possible for each individual, for human to make himself more valuable in our ecosystem, in our society. And of course, this is a data. It's always based on digital participation. It was always based on using of common digital assets, but same time to prevent leakages, to prevent cannibalization of each other. And it could be I believe in this open marketplace with, of course, based on confidential computing technology. And I believe this model of collaboration will be basic for any AI society today.
Yeah,
sorry, just to piggyback off of that, I think one of the things that I'm encouraged about confidential computing is the ability to work together in a trusted mechanism. I mean, speaking to, society as a whole, right? We want interactions, we have data, but I want it to work safely.
Exactly.
Yeah. And I believe that was the question about why Super Protocol is doing all of this. What do you aim to achieve? We also have a question: what does Web3 mean in case of Super Protocol?
Another nice question. Confidential computing guarantees privacy of model and data in use, and but same time problem is that we have system in centralized, let's say, clouds. You have system administrator who is managing your cloud service, right? And who can manage it. Of course, you can't prevent it. But same time, we use Web3 compliant ecosystem. We use blockchain, where you can program all processes behind of your, let's say, front end, behind your business model, fully managed, governed by smart contracts. It's a trustless architecture. In using Super Protocol, only you managing this whole vertical of applications, smart contracts, data, models, everything is like your crypto wallet, let's say. You're managing whole vertical of your digital assets. And I believe Web3 world should be developed in this paradigm. Thank you.
Great. Great. Thanks so much. This was an insightful session, but it's not